Hello, good day everybody. My name is Vincent Danish C. Hernandez. Today I'm going to present the logic gates. What is logic gates? Logic gates are electronic circuits that manipulate voltage, so in effect, they manipulate the binary ones and zeros, which are moving around inside your computer. Logic gates and the clever ways in which they can be combined together are therefore essential to making a digital computer work. So, ang logic gates is may matalinong paraan kung saan maaari silang pagsamahin ng magkasama at mahalaga sa paggawa ng isang digital computer. Inside the computer, when there's a voltage across a wire, and it's carrying an electrical current, this represents the binary digit 1. When there's no voltage across the wire and no current is flowing, this represents the binary digit 0. Types of logic gates. So, bago tayo pumunta sa types of logic gates, pag yung pag ang isang transistor at dalawang resistor ay nag-combine, they produce a circuit which behaves in a very special way. This circuit can be represented with its own symbol, and it has an input and an output, and it's known as NOT gate. In the NOT gate, if a voltage is applied at the input, this represents the number 1, and no voltage results at the output, representing a 0. If we swap it out, if no voltage is applied at the input, representing a 0, then a voltage is produced at the output, representing a 1. That's why a NOT gate is sometimes referred to as an inverter. This behavior can be defined using something called a truth table. Here, we can see if a zero goes in, a 1 comes out. If a 1 goes in, a 0 comes out. So, the next types of logic gates is AND. This time, for the AND gate, if we apply no voltage at input A and no voltage on input B, then we have no voltage at the output. Or in other words, if 2 0 goes in, a 0 comes out. And if we apply a voltage at the input B but no voltage at the input A, then there's no voltage at the output. Or in other words, 0 and 1 going in will produce a 0 coming out. If we swap the input around so input A is high and input B is 0, again we get a 0 coming out. But if both inputs are high, we have a high output. Or in other words, if 1 goes in, there's a 1 at the output. So, meron din ditong truth table. As you can see, if only A and B are 1, the output is 1. And the other combination is we produce a 0 output. In the case of an OR gate, if both inputs are 0, the output is 0. But if 1 or the other input is 1, we get a 1 out. Lastly, if both inputs are 1, we get a 1 out also. And here's the truth table which describes the behavior of an OR gate. You can see that only when A and B are both 0, we get a 0 out. All other combination of inputs give us a 1 out. To summarize, then these are the 3 main logic gates which you need to know, and the truth tables which describe the way they behave. And that's all. Thank you for listening. I hope you gain knowledge to my presentation. Thank you.